Distribution at Papa Home for Girls Orphanage, accompanied by donation of 50 desktop computers under CSR. Bike rally organized by young officers. Rehabilitation of farmers on ROU by Pipeline SBU. On July 9th, Nitish Singh conquered Mount Kinabalu, Malaysia's highest peak at 4,095 meters in just 19 hours, a remarkable personal achievement. Inspired by these elements, HPCL continues to lead with innovations that protect our environment and uplift communities. Looking ahead, we are dedicated to forging a future where sustainability and progress go hand in hand, ensuring a brighter world for generations to come.
करके आया नया पल, नए पल में पलता हुआ वो नया कल, नया दौर ले करके आया नया पल, नए पल में पलता हुआ वो नया कल, की बेला वतन में हर्ष है, महारत्न HP का स्वर्णिम वर्ष है, महारत्न HP का स्वर्णिम वर्ष है, नई भोर में नव क्षितिज पर है दृष्टि, जतन से रहे पंच तत्वों की सृष्टि, यही शक्ति वायु अग्नि जल चिकरे मन में ऊर्जा गंसी, बड़ी सोच की दूरदृष्टि लगन सी, नवाचार विरत पवन की लगन सी, धारा झूमती है खुशी में मगन सी, नवा से जो बहता तरंग, ये भारत नया है, ये भारत नया है, ये भारत नया है, ये भारत नया है।
In the bustling city of Mumbai, a legacy began in 1954. The Mumbai refinery came into existence as SO standard with an initial capacity of 1.25 mmtpa. The Lube India refinery followed in 1969, a joint venture between SO and the Government of India, producing 165,000 tons per year of lube oil-based stock. Soon after, in 1974, as part of the nationalization of oil companies, the Government of India took over SO and Lube India, forming what we know as Hindustan Petroleum Corporation Limited, HPCL, marking a new saga in the country's petroleum sector. Over the years, the refinery has seen major additions to its crude processing capacity, A new crude unit with a capacity of 2 million tons per year was installed in 1985, primarily for processing Indian crude. The refinery underwent expansions in 1995, 2014, and 2021, adding new units to meet evolving product demand and specifications. Capacity increased to 6.5 million tons per year in 2009, 7.5 million tons in 2014, and 9.5 million tons annually by 2021. Maintaining high safety standards has always been paramount at HPCL, achieving the highest ever safe man-hours, with 37.77 million safe man-hours recorded until February 6th. The enterprise's commitment to energy conservation and environmental sustainability is evident from its achievements. The refinery won the second prize in the National Energy Conservation Award (NECA) 2023 for the petroleum refinery sector and achieved its lowest ever Energy Intensity Index (EII) of 96.5 in 2023-2024, down from 102.7 in 2018-19. The use of new R&D chemicals like nitrate HP2 and BCA have been initiated, demonstrating focus on cost leadership and innovation. HPCL's CSR initiatives include installing air purification systems in gardens, conducting tree plantation drives, constructing school boundary walls, and supplying medical equipment and school supplies. Digitization has been embraced to enhance operations within the company. Initiatives include the deployment of an AI/ML hybrid model for process optimization, the installation of an online digital speed monitoring device for traffic safety, and the commissioning of wireless UT sensors for real-time thickness monitoring. The HP GPT digital search engine was introduced for technical data, and significant progress was made in mechanical completion and commissioning of various units and systems. Several groundbreaking projects are underway, poised to redefine industry standards and drive innovation into the future. Lube Modernization Project. Installing an integrated hydrocracker and catalytic dewaxing unit to increase lube production capacity from 475 KTPA to 802 KTPA. Focus on grade 2+ and grade 3 base oils to enhance market share. Bottoms Upgradation Project. Installing a solvent de-asphalting unit, boosting bitumen production capacity from 586 KTPA to 1045 KTPA, now producing VG30 and VG40 grade bitumen. Refinery off-gas PSA, processing hydrogen-rich off-gas streams to recover around 13 TPD of pure hydrogen. Crude oil terminal. Developing storage facilities at Jawahar Dweep for crude, MS and naphtha, enhancing storage capacity and reducing monetary losses from berthing and demurrage. Propylene recovery unit. Isopropyl alcohol, setting up units for producing 140 KTPA of chemical grade propylene and industrial grade isopropyl alcohol. Treated distillate aromatic extract TDAE. Developing an environment-friendly RPO from lube oil extracts with engineering studies completed for a demo plant at the Mumbai refinery. As HPCL continues its journey of excellence, it stands as a beacon of progress and responsible leadership in India's petroleum industry. With a legacy built on innovation, safety, and community impact, the refinery looks forward to shaping a sustainable and prosperous future for generations to come.
The Research and Technology Hub of HPCL, HP Green Research and Development Center has grown significantly as a pioneering energy research organization in the country today. With a focus on making energy and chemicals accessible and affordable to everyone through innovation, the HP R&D emphasizes indigenization and development of novel technologies and catalysts for refining, petrochemicals, green energy, additives, and specialty chemicals. Starting from a makeshift lab in a garage to converting a defunct warehouse into functional labs, HP R&D has come a long way, fueled by the determination of its highly knowledgeable scientists. HP R&D was established with 9 research labs, focusing primarily on refining technologies, PSA technology for hydrogen purification, HP High Gas, the first of its kind intensification technology for gas separation. HP Square FCC technology for high olefin production. Spray Max FCC feed nozzles for enhanced conversions. HP Fernocare for improved heater performance and bioactive.
A very good afternoon, everyone. Good afternoon. I hope you all had amazing time, enjoyed your lunch. Yes, I hope so. All right, so we are now about to start our next session, which is India-US cooperation on green hydrogen sector. And for the same, I would now like to invite our moderator out here on stage. Let's get our hands together and welcome Dr. Sunita Satyapal, Director, US Department of Energy's Hydrogen and Fuel Cell Technologies Office. A big round of applause, please. I would now like to invite our speakers, our panelists out here on the stage. We have here with us Mr. Abhay Bakre, Mission Director, National Green Hydrogen Mission, MNRE. Loud applause, please. I request Mr. Chintan Shah, Group President and Global Head of Strategic Business Development and Policy Affairs, Renew Power. Loud applause, please. I request Mr. Kareem Afzal, Executive Chairman, PDC Machines. Big round of applause, please. We have here with us Dr. Balsu Lakshmanan, Chief Technical Officer, Versogen. Loud applause, please. I would like to invite Mr. Anil Kale, Sales and Business Development Leader, Accelera, Electrolyzers, India. Loud applause, please. And also, I would like to invite Mr. Kiran, Alla, Senior Director, Business Development, Plug Power, India. Loud applause, please. I would now request our moderator to start the session. Thank you.
Well, thank you so much. Maybe we can do a loud applause for that great introduction. And so first of all, thanks to all of you for staying, because I know it's close to the end of the conference. And so we saved the best for last here. So we'll go ahead and get started. And the main thing I wanted to mention is for those who are not aware, we have a high-level US India collaboration, a bilateral, and hydrogen is one important component. You may have seen President Biden and the Prime Minister Modi joint statements. And so this is one in a series of activities of, how can we strengthen the collaboration between the US and India? So we'll hear from the speakers and we'll have some discussion. And so the first thing I'd like to do is turn it over to my co-chair, Mr. Abhay Bakre, for some opening remarks.
Yeah, thank you, Dr. Sunita. Thank you, all the panelists here. And let me first thank all the delegates and the companies who have participated in this 3-day event. Indeed, it's pleasure to have you all here. So I recently taken over as the mission director in this ambitious National Green Hydrogen Mission. Most of you are aware it's a $2.5 billion public funded mission, but with the potential to actually mobilize almost $100 billion in the coming 6 years. So mission deadline as of now is 2030. Primarily, the public fund will be used for incentivizing the production and the supply side capacity within India. If we start from the incentives for the site program, that's almost the 2/3 of the money will go to the site, which is the incentive program. For the hydrogen production, we already awarded almost 400,000 plus capacity. Second Second tranche is already in the bidding, and most of you have already participated in that. Additionally, we have already incentivized the manufacturing of 3,000 megawatt of electrolyzer capacity. That's already finalized. It was oversubscribed, but we are finalized. Now, apart from that, if we talk about the incentives, the overall objective was to develop an ecosystem where we can create facilities for production, and then with the aim of managing it, its transportation, handling, then deployment. So deployment at both within the country, wherever it is possible, and that is another thing which we need to evolve. And of course, considering the fact that there are many countries, and especially the developed countries, who have a stringent target, or I can say an advanced target in terms of GHG mitigation. So all of them will be given a kind of a solution as a green hydrogen alternative fuel for them to mitigate or decarbonize their economies. The decarbonization for India is already happening, and we have a net zero goal by 2070. So this capacity will also help our own industries to actually get into the track or the trend through their projected territory for them. So in this regard, when we talk about the demand sector, the mission, it's already running for different pilot schemes. The pilots for transport sector, we would like to create and actually see the performance of pilots like buses, trucks, cars. At the same time, steel plants, we have called for the proposal, and we are at the stage of finalizing some of them in different aspects or applications of green hydrogen in the steel sector, whether it's a DRI or whether it's a blast furnace. Then there's pilots on the shipping sector, both from the shipping as a fuel for them or as a bunkering facility. These are the three major pilots. We expect many more sectors to come. And finally, the R&D scheme. The research and development in this area, we want to actually come out with different proposals. We have more than 300 proposals. So we believe that we will try to award these research projects also very soon. All these things will require a lot of skill manpower. We have a good funds for the skilling, and that's also another thing. We expect almost 600,000 jobs to be created through this skilling program. So this is the mission status. And I believe once we talk about these kind of ecosystem getting evolved in different parts of the world, there is a huge potential for collaboration. I look forward for the corporates here. I would be very keen to see and listen to them, what kind of their proposals or their ideas are there, where we can strengthen this partnership among the two important countries in the clean energy sphere to actually advance for the hydrogen landscape. And that's very important because it's being watched from the apex level. So that's the importance for this partnership. And I look forward for the comments and the suggestions from all the corporates here. Thank you. Over to you, Chair.
Great, thank you. And so I think it's a big congratulations to India and also having the new mission director. So I think that will be really helpful to accelerate progress. And then, as I mentioned in the first day in my plenary, also in the US, we have a hydrogen interagency task force. So just like you have many ministries here, and maybe I should ask, how many of you, is there anyone here from the government or from another ministry? You can raise your hands. Oh yeah, PESO, which is great to see. And how many here from industry, if you want to raise your hand? Industry, great. And what about universities? Any universities? Yeah, and industry. National institutes or labs? Any investors? EPCs? Okay, great. What else did I miss? Students? Yeah. Lenders, investors, I said lenders. Okay, there are many that, okay, nonprofits? Okay, okay. So, but I think mostly from industry. So I think that's the focus here. And so what we'll hear is, so on the government side, we have a whole of government approach. So for example, so we're really counterparts because I'm also the director for the Hydrogen Interagency Task Force in the US. And we know that there are a lot of challenges across the value chain. So we're talking about hydrogen production, electrolysis, plus other approaches, and then delivery and storage, pipelines. It's great we have PESO here, safety, and then all the different end uses. So whether it's transportation, trucks, buses, the fueling, industrial, ammonia, chemicals. So it's just such a huge value chain. So what you're going to hear today, we'll have a snapshot from Renew Power. So, large scale integration, obviously renewables, electrolysis. And then we'll also hear from PDC machines. So compressors, some of you might be familiar with, the refueling, simple fuel. So that side of the value chain. And then we're also going to hear just one example of innovation. So kind of next generation technologies, AEM, alkaline exchange membrane. So kind of an early stage startup. And then Accelera. So having Cummins that already has a strong collaboration in India, for example, with Tata Accelerator, the electrolysis space, and then Plug Power, which also is active in India and has both the electrolysis and the fuel cell side. So that kind of gives you a snapshot of slightly different areas across the value chain. So we'll hear from each for about 5 or 10 minutes, and then we'll have a moderated Q&A. So the first we'll start with is Mr. Chintan Shah, who is the Group President and Global Head of Strategic Business Development and Policy Affairs from Renew Power. So please join me in giving him a big welcome.
Yeah, thank you, Sunita, Dr. Bakre, and good afternoon, everyone. I'm the first one to talk about it, so I'll a little bit talk about what's happening on the India front. Renew is one of the most integrated RE company of India. We are an energy transition company. We got about 10 gigawatts of operating capacity, and we are pursuing close to about 2 million tons of hydrogen projects in India at various stages. What's important to know over here is hydrogen is going to essentially integrate almost everybody, every institution in India, because you start from renewables, get into transmission, which is government, get into production of hydrogen through electrolysis, which is a very different technology. The renewable sector is doing it for the first time. And you get into ammonia production and transportation of the same towards a thing. So it requires a very complex way of integrating things together, and everybody has to be in harmony. Interesting part about India is renewable sector itself is being pushed by 90% by the private sector, while oil and gas traditionally has been government. So we are getting into an energy field which is going to replace to a great extent hydrogen produced from the fossil fuel. So you have one way of coming from the renewables, which itself is a disruption. When renewables started off in India, it started disrupting coal, because in coal projects, you cannot predict long-term energy prices. It changes every year. But renewables able to produce electricity at a constant price for the next 25 years because there's no fuel involved. It's only finance cost. The same is going to happen in hydrogen. You don't have a long-term fixed price contract in hydrogen today because it's dependent on an oil and gas prices. While because it's been driven from renewables, you'll start able to offer long-term fixed rate contracts, which itself is a disruption in this entire sector. But it's very important to have a long-term supply contract or purchase contract to have the financial closure and bring the hydrogen prices lower. If you have a 5-year contract or a 3-year contract at a fixed price, the prices for hydrogen will shoot up because you don't know what's the uncertainty going to happen later. Since I will put up a renewables, it's going to generate electricity, it's going to produce hydrogen irrespective of that. So that's one particular thing that I'd like to put over thing over here is that it's important. It is initial phase till the hydrogen markets develops. We should aim at a long-term price contracts. Otherwise, this sector will not be able to scale up as we would like to want it. And that's the start point of it. And this is something which has been happening. We've been talking about with government within domestic market also, global markets also. Let's have, we're not talking about 10 million contract, 50 million contract. We're talking about at least a 1 million ton contract. Let's have it long-term contracts. Either it can be through CFD also, for example, contract for difference also, but you require some visibility in the hydrogen front. That's particular thing. Now, India is essentially poised at a very important epoch of time, because as we know that 45% of the cost of hydrogen comes from energy, renewables. Today, India is able to produce electricity in solar side at sub 3 cents level. We all know this on a long-term basis. That's the key to it. And that's probably the cheapest in the world. And this is including all taxes and Indian cost of capital. The moment you're talking about hydrogen for export purpose, this 3 cents gets reduced to about 2 cents. You don't have to go for a hedging cost. And you have a dollar type of a debt as well as equity. So you have already possible today to produce at 2 cents. Now that's the game changer, because when you 45% of the entire hydrogen cost is electricity, we are already at one of the lowest minimum standards in India. Going forward, it can also come down to 1.5 cents, 1.2 cents. We don't know. It depends on the economies of scale. So India is today poised. If you knock out all taxes, all incentives and all, the cheapest source of hydrogen producer. That's the fact. You can always add policies, incentives to it and reduce it further, add taxes to increase it further. But on a pure economic basis, we are poised today to do it, because we already have a massive program on renewables side to put 500 gigawatt of renewable 2030. So we have that economies of scale on the energy side. What we do is in the downstream part of it, putting electrolyzers, putting the ammonia unit and ship it out, and the transportation, for which I think the hydrogen mission is working very well. From the industry side, is very important between US and India. We need to work in harmony in terms of standardizations also. Because the whole idea is that India is going to also export a lot as well as consume internally. For exporting, it's very important that all governments or off-takers, and this is where the government's role comes into picture. When a contract gets entered from B to B, it's important of harmony of standards is important. Be it storage, be it how do you define green is also equally important. Now, just to add one more thing to you, this is India is also at the same time developing about 60 to 80 gigawatt of pump storage hydro, which is also very important to essentially to remove the variability of the solar and the wind and make it a scheduled power to be consumed at an electrolyzer level to increase the efficiency of the electrolyzer. This is all things are happening in bits and pieces in India. If you see them the entirety, we are poised to become one of the biggest hydrogen player in the world. And obviously with US as a partner, it's very important that we work together at all levels, including skill development, because we require skilled manpower also. We have technology transfers also. We have to work on a manufacturing basis also and supply chain basis also, because your entire supply chain is also needed to feed in all the raw material needed. So this is something which is good that we are doing. And I hope that this continues in the right directions. And I would also suggest that please involve industry in all this dialogues and all, because ultimately we are there to deliver also. Thank you.
Great, thank you. And just for awareness, there is under the Strategic Clean Energy Partnership, the SCAP, there is an industry task force specifically on hydrogen, and it's chaired. There are different subcommittees, so transportation, the fueling side, production, and so forth. So it's actually chaired by industry. So to your point, we completely agree that it needs to be market driven, and we're here as enablers on the government side, but we really need to accelerate progress to industry. One quick question on the cost of renewables. You mentioned 3 cents and 2 cents, but that's still subsidized, right? So even without any subsidies, you can get to 2 cents and 1.5. Okay. Because one point of mutual interest globally, in fact, is Europe or parts really need hydrogen imports. We know Japan, Korea, certain countries. And in Europe, the Renewable Energy Directive actually, if it's subsidized renewables, because in many countries, the renewables have to have some subsidies to ramp up and get to scale and deployment. But if it's subsidized, then that hydrogen would not qualify for import. So that's one example of a policy barrier right now, and where it's helpful, where countries can get together and can explain what the challenges are. And so I think we'll have time for questions later, but I think that's a great opening, and a big congratulations to Renew Power, because I know you've been the forefront here. And if you get to the 2 million tons, that's huge, right? A huge contribution. So the next speaker is going to be Mr. Kareem Afzal, who is the executive chairman of PDC. And I think for some of the US companies coming here, they'll give a short presentation. How many of you have heard of PDC? Okay, so a couple. So and Simple Fuel. So I think Kareem has some slides, so we'll turn it over and you'll hear 5 or 10 minutes from each speaker.
Is it sharing? Oh, they're doing. Okay. Yeah. On the screen. There we go. All right, everybody. Thank you, everybody. I'm really excited to be here and share a bit about PDC machines and how we have leveraged our work and collaborations in other parts of the world, and how we're planning on bringing that here in India with our great partner, Kale Pneumatics. At PDC Machines, our purpose here is to lead the energy transformation with hydrogen solutions and specialty gases. We do this in a variety of different ways, being the best in customer service and support. Especially PDC is very active in the hydrogen mobility space. And the user experience is ultimate and paramount. And the ability of hydrogen to be transformative in this space for heavy duty material handling and eventually light duty passenger cars, it only goes as far as the user experience in terms of uptime and reliability of the equipment. And at PDC, we value this at the highest level. We've talked a lot about cost at this conference, and scaling to mass production to bring the cost per kilogram delivered to the customer is of the utmost importance. Hydrogen is able to be the energy carrier of the future as we're able to reduce these costs to the customer or the consumer or the user. And we want to anchor and innovate and anchor with our customers. And that comes through varied business models, whether it's selling equipment directly or own and operating and selling kilograms of hydrogen in various business models. And at PDC, we're bringing those things to market, as well as equipment that can fuel a variety of things that will help transform society as we move into a decarbonized future. We work on a world of use cases, from bus fleets to the world's first mining fleet in South Africa with the Project Rhino. Working with one of our key partners here, Plug Power. They provided the electrolyzer, PDC provided the compressor, which is the world's first in the 300-ton mining hauler. Public transit is a huge opportunity to decarbonize our cities, right? Public transportation in our cities provides some of the most pollution that our residents in large and densely populated cities are active in. And I have some examples here of our machines in the field that have helped decarbonize very large populations. Last mile, medium duty and heavy duty vehicles. Of course, these large consumers of hydrogen are going to help bring the cost of hydrogen down, and PDC is at the forefront of that. And of course, one of the world's first commercial use cases, material handling, where our machines are in hundreds of installations around the world, helping to bring hydrogen into indoor warehousing. We have a variety of products that we make, from bare compressors to package systems to complete integrated refueling systems. These are very important and critical at all parts of the value chain, whether you're using mobility or whether our compressors are pumping up seasonal storage from power to gas applications and filling to high pressure hydrogen to be stored for long periods of time in order to be used later on in order to feed back into power or for mobility or some other purpose around the world. We're a 45-year history company started by my Hyderabadi father, who came to the US on a scholarship in the 60s. He married my Swedish mom, stayed there and didn't go back. And then sort of this history is from there, starting in his garage and growing slowly over time. Now, today we have 1,400 hydrogen energy compressors around the world. 1,000 of those are in a variety of mobility applications around the world. Here in India, we have done, lots of people have talked about the National Solar Center. So our compressor is being used in that for about the past 10 years, as well as at the IOCL refueling station for even longer than that, filling a variety of buses, forklifts, and other things that they have going down there in Faridabad. So very excited. We have 60 individual installations and machines here in India, primarily in the power sector, where they use hydrogen for cooling turbines in autothermal power plants and power generation. And we're very excited to have announced in April our tie-up here with Kirloskar, the Kirloskar family company, Kirloskar Pneumatics, a really key innovator here, specifically in the CNG market, where they have relatable talent and innovations going into the Indian market at thousands of installations and mother and daughter CNG stations. And PDC will be providing our high pressure compressors to Kirloskar as a bare unit, and they will be integrating and providing the installation, commissioning, service, and support to the market here in India. And we couldn't be more proud and honored to have this partnership with Kirloskar based in Pune. And we've had a team already come for a set of training, and we're going to be bilaterally hopping across the pond, so to speak, to work on building our cohesive teams together in order to affect the market. And since that, our tie-up, we have been sort of marching along the market and really finding unique and varied business cases here, from heavy duty to bus filling to stationary power applications that are really truly unique in the context of the rest of the world that we've seen. So it's something that we're really proud to be a part of. I'm going to skip Kirloskar's journey. It's about 130 years of innovation and a variety of process gas refrigeration, CNG, hydrogen, and other gas compression. At PDC, we have deployed a variety of products around the world, and all of these are in partnership with our local partners. In the end, a lot of hydrogen energy and the renewable energy industries grow together when we're able to share technologies, but also grow the job base and grow the technology base in the local market that we're working in. And it's something that we feel is extremely important in any market that we're going. This product that you see here is an output of a Department of Energy contest that PDC and our partner Ibis Energy Solution won, which was the H2 Refuel H Prize contest, which challenged American innovators to create a small on-site hydrogen production, compression, storage, and dispensing solution. We won that in 2016 and have since commercialized this technology, and we're deploying this around the world. And what you see here are installations in Japan, Australia, and the United States, filling a variety of end-use applications, from material handling equipment in Toyota factories in Japan to Toyota forklifts and Toyota parts distribution in Australia, to another DOE-funded project at the University of Texas, Austin, filling a variety of fuel cell vehicles, and also filling 350 bar hydrogen that ultimately will be used for UAV type applications. It's very compact. It's about the footprint of two of these tables put together, and it has electrolysis, compression, storage, and dispensing within it. The world's leading experience in warehouse and material handling, the biggest user of industrial hydrogen in the United States and North America. We have hundreds of installations with this partner plug, from 50 kilogram a day all the way up through multi-megawatt sites, taking boil-off gas from liquid hydrogen, in some cases taken from electrolysis, some cases taken from delivered hydrogen. Working with partners in Korea, and we have multiple partners in Korea that provide refueling solutions to the Korean market. We have about a third of the market in Korea. This particular one is at Gimpo Airport. It has 3 dispensing points for buses and light-duty vehicles in this location. Each compressor is capable of about 1,000 kilograms a day. Total is about 2,000 kilograms a day. And other installations here in Incheon Airport, Seoul City Hall, and others. This is another example with a partner developing clean. This is a zero-emission bus fleet at the at the Mass Transit District of Urbana-Champaign, Illinois, 2 hours south of Chicago, taking 1 megawatts worth of electrolysis. In this case, it was an electrolyzer, and PDC providing the refueling equipment in order to fill 23 buses in a 3-hour very aggressive profile. Hydrogen comes in different ways, low carbon hydrogen, clean hydrogen. To Sunita's point in her plenary in the day one, we don't like to talk about colors necessarily. This is blue hydrogen. But it's net zero hydrogen, taking biogas from trash facility and be able to fill city buses in Tokyo. This also with local integrators, growing the job base, supporting it locally, we providing the bare compressors and the technology in order to drive that. China, we have 7 partners. We started at the beginning of the journey in China, and now we have 138 stations worth of equipment, fueling a variety of hydrogen buses for city, medium duty vehicles and whatnot. And then I'm a sports fan. Andy Marsh is a Philadelphia Eagles fan. We cut my arm off, green would come out. We were able to put a hydrogen refueler at the Philadelphia Eagles football stadium, Super Bowl champions this year, I hope. We say that every year. Filling, anybody who's a sports fan says this is our year. So this is our year. And filling Hyundai Nexo vehicles as well as forklifts that'll be joining their fleet this year. You know, if I want to leave with a parting statement here, really the collaboration between the US and India is really key. And we think we're honored to be a part of, and we're really excited to see where this goes into the future. And PDC is proud to be here with our partner, and we look forward to seeing what comes in the future. I said last night at the roundtable, we've been involved. I've been involved this in 27 years, all the way back to Sunline Transit, which was one of the first hydrogen filling stations in the US. And we've seen different slopes of development in every region. I think India has the opportunity to be one of the steepest slopes in terms of its growth. And we look forward to hopefully having the right policy framework and whatnot in order to take advantage of that. With that, I apologize for being a little over time, but thank you.
Thank you, Kareem. And I think this was a really nice, it's an American small business success story. And I think a nice tie-in with India, because his father came from India and went to the US, and then his mother came from Sweden. They founded this company. Now he's the executive chairman. So nice, you know, family business. And how many employees do you have now?
120.
120. And they actually were very active in hiring veterans. So maybe a decade ago, we gave them an award, and they actually got to meet Michelle Obama, and we had some nice, and you know, won the prize. So great example. And I think with the partnership with Scar, what we're looking at is how do we make 1 + 1 greater than 2? Because you know, we really have to accelerate progress and have a win-win on both sides. So benefit on both sides, jobs, you know, local manufacturing. So these are the kinds of things we want to promote. And so with that, we're going to switch over to Dr. Balsu Lakshmanan, who is the Chief Technology Officer for the small startup Versogen. So we'll hear kind of a different side of the spectrum on some real innovation. Again, we're looking at, you know, how do we leapfrog and look at some lower TRL innovative technology.
Absolutely. Thank you, Sunita, and thank you, Bakre, sir, for this invite. I'm going to talk about Versogen. We are a leading anion exchange membrane company and one of the leaders in developing the anion exchange membrane stacks. Like Kareem, his father went from India. I did my undergrad back in India. I mean, now we are in India, sorry. Humble beginnings, small town, interior Tamil Nadu. Did my undergraduate degree in Karaikudi, graduate school in US, and worked for GM for 20 plus years. And then a non-founder CTO of this company, because I truly believe this technology is going to help not just US, but India leapfrog how we make electrolyzers. A little bit of a company overview. It was spun out of University of Delaware. We are based in Newark, Delaware, about 20 miles from where PDC Machines is. 25 employees. We are a tech-heavy company, about 50% PhDs. For a company this size, this early, we have revenue. We are growing revenue company. 10 plus patents. We already have over a gigawatt per year of membrane production capacity. This is anion exchange membrane. And we have scaled up the stack platform to test our membrane. We did Series A funding 2 years ago. Now we are in Series B. What is our current product? Our current product is sold under the name of Piper Ion. We make these membranes commercially available. Anybody from anywhere in the world can buy it. We actually sell to over 100 customers in 60 countries, put in 3 different groups, Europe, US, and China, equally having 25% each, and the rest of the world having the rest of the 25% in our sales. We have a lot of investors who are mostly strategic investors. I don't have to bore you to death with the AEM technology. It gives you a very simple way to split water that mimics the liquid alkaline without using highly caustic KOH and being able to do that with the membrane, right? What does it mean? Basically, think of this. I'm going to now make a joke with Kareem. A beautiful combination of an Indian and a Swedish mom. You got a great chairman. That's what you're going to get with AEM, right? You take liquid alkaline, a stable old technology, PEM, an attractive technology because it can do a lot of things. But when you put these two together, you're going to get AEM, right? That's our benefit. That's what's shown in the chart. But I can simplify it down to being able to say, look, you're going to get a 1 megawatt AEM stack, the size of the half of this dais. Very, very similar to in size to a PEM 1 megawatt stack. It's not the size of a small Maruti car when you look at it from an AEL, right? That's the first biggest advantage. And there is inherent safety built in because this uses a membrane. Membranes have low hydrogen crossover, which makes the system inherently more stable. Energy use is somewhat in between liquid alkaline and PEM. Turn down ratio, that is absolutely required when you're tying all these electrolyzers to renewables, being able to go up and down in power level. And the cost is very, very, very close to liquid alkaline. Not at that cost yet, but that's what we project. That's for AEM. When you look at why Versogen is the leading maker of AEM. We have a technology that is very, very scalable. We actually have scaled it. That's why we can sell it to anybody in the world. Its alkaline stability and ionic conductivity are the best reported, not just by us. You look at studies from National Renewable Energy Lab or ZBT in Germany or the Imperial College in UK. They all have come to that same conclusion that when you test an AEM from Versogen, it has the best performance. And we have the class-leading KPI, and we have gigawatt scale. Why are we able to do this, right? What is our value proposition? Our company is tech-heavy. We have PhDs working on making new polymers. We have process engineers who can make the membrane, and we have stack designers and stack test engineers who can put that into a stack and test it. That's the reason why we have been able to go from what you call as a TRL3 membrane or a polymer all the way up to technology readiness level 6 quickly. Matter of 18 months, matter of 20 months, we can take a new concept from something that is cooked in a lab on a gram scale to be able to test at a 10 kilowatt stack. And this 10 kilowatt stack is scalable up to 300 kilowatts. We chose not to do the 300 kilowatt because that's not what is required to be a membrane company. We did that with a 10 kilowatt stack. That's the reason, that's our value, being able to go from polymer to a stack under the same room with key people who can collaborate and make it happen. Our products, 20 to 80 micron membranes, different thicknesses for different applications, very good strength, very high conductivity. And of course, we do have these in stock. It's not like you order and then we go buy the ingredients later to make this. we have hundreds of square meters in stock. And if you want thousands of square meters, of course, yeah, we have to plan for that, right? This is made in a roll-to-roll format, high volume throughput. And I leave you with this, right? So we definitely want to enable a rapid transition to green hydrogen. And that can be done when we cross-collaborate and leapfrog existing technologies and make it happen by working as a team, one company, one group. Thank you.
Great, thank you,
Thank you.
Balsu. So again, what we wanted to do here is give you a snapshot of something that's really cutting edge, the innovation. You think back when we funded, or even some of the other things like with PDC Simple Fuel. So that's where, the government can come in and try to help incentivize, in this case, pre-certified. We have PESO here in terms of safety, something that can, easily be deployed kind of with the, pre fab. And then here too, cutting edge innovation. I think the spider charts are great, as hopefully you all know that with DOE targets, we're always emphasizing DOE targets. And so it's great to show status compared to the targets. So it gives you a flavor of, what's possible. And I saw lots of people taking pictures. So maybe you'll get some customers. But now what we're going to do is transition to some more established player. So I think you all know Cummins, and they rebranded with Accelera, lots of good collaboration globally in many areas. And so we'll turn it over to Anil, Kale from Accelera Electrolyzers.
Can we put the presentation on the screen, please? Yeah. So good afternoon, everyone. And first and foremost, thank you, MNRE, DOE, for giving us this opportunity to be on the panel. I represent a company called as Cummins. We have recently launched a brand called as Accelera. That is acceleration towards net zero. That is what we facilitate our customers doing it. And that's how the brand Accelera. What I will do in the next maybe 7 slides is to just take you through first what my company is, what are the products that we have, and what kind of projects that we are executing in the markets to accelerate this shift. So first and foremost, Cummins, global company, as Sunita talked about, a representation in 190 countries. We just 3 years back completed 100 years. Very few companies in the industrial setup which have completed 100+ years. So we are one amongst them. Roughly $35 billion of revenue globally. And India, particularly, very important focus market for Cummins. We are there in India for the last 50+ years. The core business of Cummins is certainly engines. You can think about the engines for any applications, commercial applications. We are not into small applications like cars, but any applications, trucks, buses, heavy duty, rigs, refineries, railways, all those engines we make. We're also big players on the power gen. So engines is certainly, again, the bread and butter of Cummins. We also have components and distribution set up. Distribution because it's a traditional B2B company, but it's important that we have the legs and ears in the market in order to support customers. So we have a dedicated distribution business unit for supporting the customers once the product sale happens. On the Accelera side, as I talked about acceleration, that is what we are talking, and all the new products, be it the batteries, fuel cells, electrolyzers, hydrogen storage systems, all those products which are under development and we are getting into the market, all that comes under Accelera with Cummins. And I take the pleasure to have this from a sales perspective for India market. This is an important slide. I just want to spend a couple of minutes on this. It's a destination zero strategy for company. As you know, we have the core business and we have the new business. So we have to have the balance and balance from the point of view of market. It's not only from the point of view of growing the company. So there are 4 pillars broadly. One is how can we lower the emissions today? So we're talking about the new gen of engines because we believe we will be the last person in the queue to offer the engines to the market. We're not leaving that space. So we're innovating on the engines, diesel to natural gas. We are also building the 100% hydrogen-based internal combustion engine, both for India and global markets. The second pillar is how we can reduce well-to-wheel emissions, because that's important. It's not just about how we reduce emissions on board, how we reduce the emissions well-to-wheel, and that's where the storage comes into the picture. Drive wide-scale customer adoption in terms of hydrogen economy. So both on hydrogen generation, storage, distribution, those are the sectors wherein we are going to get in. And the company's target is to achieve net zero by 2050. Not easy for a company which has got a core business on engines, but that is what the commitment is. We talk about three broad areas. One is while we talk about 2050, India is talking about 2070, we still need actions today. Progress requires partnership, specifically on hydrogen side. We had a dialogue, but Renew just a few minutes back. He talked about how complex the entire model is. So we need partnership between electrolyzer players, EPCs, compressor manufacturers, and of course with customers. And of course, technology becomes critical because this is a new business. There is a lot of uncertainty on the financing side, reliability, durability. So technology plays a key role. This is one slide on the products that we have on electrolyzer. I will not spend more time on that. If you have any query, please reach out to us. But broadly, we have the IP and technology on both the sides, on the alkaline and PEM, which are fairly established technologies. On a smaller scale, for 100 meter cube, we have a range on alkaline. But all the larger applications, 500 meter cube per hour, 1000 meter cube per hour, 5000 meter cube per hour, we are building the products and we are introducing the products on a PEM technology. So if you look at the stack there, it's a 1.25 megawatt stack. Of course, it's an extremely compact stack. And we also have a 2.5 megawatt stack, which is one of the world's compact PEM stacks available on a commercial basis. These are some of the projects, just few glimpses, what we are doing globally and in India. We have about 500 plus electrolyzers installation globally. In India, we have deployed around 15 plus electrolyzers thanks to our acquisition to Hydrogenex that we have done in 2019. But we have a very strong footprint in India on the electrolyzers as well. So this is the world's first largest PEM electrolyzers in operation. We introduced that for the air leaky at a place called as Bécancour in Quebec. So what you see there, those are our modules. 4 modules are in operation, 5 megawatt into 4. Roughly producing about 8 tons of hydrogen per day very successfully for air leaky in Canada. And that was in 2018. That's the first project. The large scale project, I'm talking about 10 megawatt plus kind of projects. We have recently introduced in US, this on again on the Hylizer 1000. Hylizer is basically the brand what we have on a PEM platform, and 1000 talks about 1000 meter cube per hour. It's a 5 megawatt module powered with a 2.5 megawatt, 2 stacks. So this is a 25 megawatt setup. So we offered the 5 units for Florida Power and Light. And the YouTube video is available. Please feel free to see both our Bécancour and this YouTube video on the Florida Power and Light, how the hydrogens are being powered by using the renewable energy and what's the usage they're doing with green hydrogen. Very important on Cummins. I said Cummins is an extremely important market for Cummins. We are proud that we are collaborating with our EPC partner and end customer Gas Authority of India Limited. And we are in the final stage of installation commissioning of this particular project. We are almost done on the I&C side of it. It's a 10 megawatt, which will produce about 4.2 tons of a clean hydrogen at a place called as Vijaypur. And Gale will be using that clean hydrogen for multiple applications. So we are very proud for this first large PEM project installation in India. This is my last slide. I just want to leave the dais with few thoughts with the audience. One, as I said, we have 500 plus electrolyzers worldwide in all favorable and demanding green hydrogen use cases. Second, our global manufacturing capacity. For the paucity of time, I couldn't bring that slide, but roughly about 2.5 gigawatt kind of a manufacturing setup we have on PEM in US, China, Europe, predominantly in these continents and countries. India is certainly an important market. We are looking at how can we bring our setup in India soon. Third is, as I said, we have a very strong core business in India. We have about 50 plus years of presence. So we are leveraging that experience, that relationship with customers, collaborating with them to participate together as a partner in green hydrogen economy. And last but not the least, this is a new market. This is a nascent market. We need the ecosystem wherein you have a startups. At the same time, we have the established players, and we bring our experience as an established player. We bring capabilities across applications. So we have the capability on the on-highway, off-highway, power generation, stationary application, right? So we bring the capabilities across all applications when we go and talk to the customers, and we feel that's very important. Ability to achieve scale, right? Today, customers have a requirement, maybe 100-meter cube at the project site. But going forward, they will have a requirement for a large project like 2 million tons of ammonia. How can we support these customers, right? So we have, that experience, expertise, 100 years of legacy. So ability to achieve scale, security of supply across markets. So with presence with 190 countries, our supply chain is global. That is what we bring to the customers. And last but not least, the supply chain and manufacturing, again, in those 3-4 main countries. And of course, in India, wherein we started having our engineering center and procuring the large and important aggregates for electrolyzers for India for global and India for India projects. So with this, I would like to thank you and look forward for the engagements and Q&A. Thank you so much.
Thank you. That's great. And it's also great to see, such a traditional, engine manufacturer, big producer of CO2, and your former chairman, Tom, who I knew really well too, and now Jennifer. So it's great to see, such support at the corporate level to get to net zero. And so I think you all know Cummins, again, century of history. So now we'll, last but not least, we have Plug Power. So Kiran, Alla, Senior Director of Business Development. And we had supported from DOE side Plug Power for many, many years. A good example with the forklifts, de-risking technology. They've done a lot, liquefaction as well. So we'll hear from Plug Power.
Yeah, thank you, Dr. Sunita. Thank you, Bakre ji, and co-panelists. And thanks for this opportunity. Before going to the next slide, I would like to say that Plug is a company which believes in green hydrogen fully. So green hydrogen, we believe, is critical to green energy revolution. While green hydrogen is not the only solution, there are other solutions, but it is critical in order to achieve a fully decarbonized energy world. So that's our commitment. So we do everything related to hydrogen. So Plug, if you think about it, Plug has been around for more than 25 years. It was actually doing the last piece of the hydrogen, which is used hydrogen. So as you have seen in the other presentation by other co-panelists, we have been doing this material handling application using hydrogen. So we were replacing batteries with fuel cells and demonstrated a clear value for the customer long before green hydrogen was discussed about. Right. And it's a crazy company. It's a startup even now, even though it's a big company. We act like a startup. So we keep doing all crazy things. We started with that when the customer said, oh, this application looks good, but how do we do rest of the things? So Plug did everything, put every piece of that solution. So not just the product of fuel cell, but also on-site storage of liquid hydrogen, then hydrogen dispensing station, the compressor required, everything, put all the pieces together and provided a solution to the customer. It's almost like a hydrogen mobility as a service, not even hydrogen as a fuel. So they actually provided that. And that is how we demonstrated the value to the customer. So it's not so much about the technology or the carrier, but I think that providing value to the customer was very, very important to Plug. So that's how Plug existed, and Plug kind of grew in that space. Majority of the fuel cells in the forklift truck application are from Plug. And then that same fascination or focus on delivering value to the customer led us into green hydrogen, because customers want to decarbonize. They realize that, okay, they want to reduce their emissions. And we realize that that's an easy space where we are already using hydrogen, and making that hydrogen from gray to green is how we can help customer decarbonize. So we started with we know that the green hydrogen is enabled by the low cost solar and wind. right? So today electrolysis is attractive, not because of any other reason, but because solar and wind have scaled. And they've scaled and the cost has come down significantly. That makes electrolysis the most scalable solution for hydrogen, green hydrogen. So there are other solutions, but that makes it very attractive. So renewable is scaled. So then we said, okay, we need an electrolyzer. So let's get into electrolyzers. So we acquired a company called Gyner, which had the world's best PEM stack, and they have supplied to submarines, NASA space station, and all that. So acquired that, and we started scaling that solution. So we now have from 50 kilowatt, 100, 150 kilowatt. Now we have a 1 megawatt stack. Using that, we started building large scale electrolyzers. And in order to provide the molecule, we said we are not just supplying the equipment, but we are producing electrolyzers. So let me show you the other slides. And then we went to how do we liquefy? So we acquired a liquefaction company, then we acquired a cryogenic storage company, then we acquired even these tanker trailers by which you can transport hydrogen on road in US. So we have now built from a end-to-end, from generation to dispensing, and also the fuel cell solution, which we already have, which is scaled up now, not just for forklift trucks, but also for power generation. A 1 megawatt containerized solution is what we already supplying. We recently partnered with another energy storage company called Gravity. So we are supplying a 8 megawatt solution to them. So Plug is doing everything end to end. And we try to get into every technology that is really required to complete the puzzle. So in last 3 years, I think there has been a lot of talk about hydrogen, but Plug is a company which has been doing real things. Now, as you can see on the screen, we have either installed or in the process of installing electrolyzer across the world. In India, we already installed a 5 megawatt for NTPC in Vindhyachal, and there is one more which is coming up for a private oil refinery in India. And apart from many small stacks that we have supplied, which are sitting in IOCL R&D and many other customers producing hydrogen, the PEM stacks. And we are doing a lot of work in Europe and US and even Australia and New Zealand. So across the globe, we have now installed electrolyzers. So this is our vision that in US, we want to not only supply electrolyzers and fuel cells, but also actually build a green hydrogen network. So end to end. So we are present in the New York space, but also on the West Coast. So our plan is to build both production sites and also dispensing stations that cover the whole geography of US. Similarly, in Europe, we have similar plans. We want to build hydrogen, not only supply it to the customer, the electrolyzer, but also build plants, either sell the equipment or sell the molecule, both. As on today, we already have a 45 megawatt world's largest PEM electrolyzer plant in operations that produces about 15 tons per day, Georgia plant. And that's where we also installed a first electrolyzer hydrogen getting liquefied. Right? Normally, the liquefied plants are liquefying the gray hydrogen, but this is where the electrolyzed hydrogen is being liquefied. And that is being transported to our customer locations using our own tanker trailers. So that is producing, liquefying, and then transporting to the locations. So Tennessee is another plant where we have a 10 tons per day existing plant. We have larger plants, 15 tons per day in Louisiana and Texas, 45 tons per day. And New York is the biggest plant, 74 tons per day. And under development, we have a plan. These are some of them are in Europe. Antwerp, 35 tons per day. Finland, there are 3 sites. Denmark, 1 site, and France, 40 tons per day. So these are all happening, and Plug has been doing real things. So this is our Georgia green hydrogen plant, where we have the electrolyzer, liquefaction, cryogenic storage, and also the tanker trailer to transport liquid hydrogen. So I thought I'll share some ideas and not just focus on what Plug is doing. So I felt that US and India, we are united definitely by common interests, right? So energy security, independence, access, affordability, equity, and environment are definitely on the top of everyone's mind. It's also important to develop resilient supply chain and demand for clean technology. And one thing is very clear, the overcome China's dominant position in global supply chains is definitely on the radar. And there is a clear focus on industry and innovation, and also de-risk supply chain and limit exposure, growth and job creation. So I felt that these are the common interests, but there are certain complementary strengths. There is strong technology and IP. Like, for example, we work in India, so I'm looking at it Plug from an India perspective, but my US counterparts look at from their US or European perspective. There is a strong technology and IP available within the company, for example. But we also have a strong people strength in India. We have 150 people in India, engineers working for global projects, doing pre-sales, technical work, project management, various things. And our experience of hydrogen, like last 25 years, we do about 50,000 refuelings on a daily basis. So refueling of hydrogen is nothing new for us. And this refueling is done by the forklift truck operator. It's not done by a specialized person, no one kind of trying to manage it. It's done just like you refuel your other vehicle, right? So that experience is something we can bring to both markets. And joint TAM is something, these are the two real largest markets. And India is the fastest growing, may not be the largest right now, but the fastest growing. And obviously a very attractive investment destination. So some thoughts I thought will accelerate both India and US. I mean, one is looking at a cooperation kind of thing, but a deeper collaboration will definitely benefit both the countries. In India, you can do a lot of things. We have people, we have use cases, many things can be tried. And the US has a strong investment and strong demand and very strong incentive program. These are few things that I put as suggestions to the panel. And yeah, that's all I have. Thank you very much.
Great, thank you so much. So now we're going to move into the Q&A. And so I'll start with some, and then we can take audience questions. But unfortunately, my co-chair, Mr. Abhay Bakre, needs to go to another session soon because we have so many parallel sessions. So he's also on another session. So we'll have him, we'll see if anyone has specific questions, but I'll start. Basically, given that your organization is the lead for the national hydrogen mission, green hydrogen mission in India, if you can say a little more about, your overall priorities for the Indo-US collaboration, like where do you see the biggest challenges, and how, again, given that you're new in this role, what more do you think can be done to accelerate?
Yeah, thank you. So in this conference, during the 3 days, we deliberated a lot, and most of the issues and challenges, in fact, have been discussed, and the solutions are also suggested. Like, so as a mission, our at least the first couple of years, I may say that the challenges and will be how to actually create demand. Now, demand is known. It is known, but it is not established or it is not firmed up. So it has to be converted into clear offtakes. So what we can do? We can do that exactly the similar thing what we did it for solar. Now we are part of MNRE. We have a great success story on solar. So the solar, when the technology came up, the cost was very high. So the challenge was how to reduce the cost. But the solar energy, or what is the electricity produced from the solar, was actually pumped into grid, and the grid was already having a demand. So basically, the electricity generated by solar, and this is the key, the electricity generated by solar panels was actually blended, or slowly it was phasing out the other forms of electricity, whether it's coal or gas. Now, exactly the same thing which we are to. So to create demand or to create an offtake, we need to establish a very clear distribution, which are the sectors, which are the clear plants where the hydrogen is currently being used, and how we can start blending 1%, 2%, 5%, depending on how we are scaling up our production. So once we start blending it 1%, 2%, so that cost differential. So the two challenges, to create demand and to reduce cost, can be addressed if we start blending or replacing the conventional hydrogen by the green hydrogen in a very gradual manner. So once it is a gradual manner, the differential cost will not impact the overall product. That's what it has happened. When the solar was purchased at 18 rupees and the coal power or the thermal power was available at 2.5 rupees, when 1% was replaced, the overall impact was only 2.5 rupees to 2.6 rupees. So it was only 5 paisa or 10 paisa impact on the electricity price, because the solar powers were only 1% of the entire grid. That's what perhaps this will be the possible solution. But we will need to go into detail how the industry or all other consuming sectors are prepared to actually convert or blend this green hydrogen with the existing hydrogen. I think that will be the thing.
That's great. So I think we all know that, offtake and that certainty is critical, the volumes, the certainty. And the US early on, California, what really helped drive the vehicles is the zero emission vehicle mandate. And I know from, outsider looking in with India and Delhi, just what you did with the buses, all going to CNG. Is there anything more on the transportation side, trucks, buses, any more sort of policies, again, incentivizing that offtake or that you see coming?
So the incentives currently available with the production of the hydrogen, now that itself will basically partially, if not fully, bridge the gap between the conventional hydrogen and the green hydrogen. Now, as I said, the pilots are being already funded for the transport sector, then the shipping sector. So these sectors will get prepared themselves to absorb some kind of hydrogen. So, and then that will open more and more avenues. And yes, very true. Maybe at some point of time, we will have to do some kind of a mandate for some kind of and the decarbonization trajectory which is happening in steel sector, cement sector. This mandate will actually help them, because we are setting up their emission limits slowly as an emission intensity. So that will drive them to procure more green hydrogen in a phased manner, maybe a little bit at higher cost, but still that will actually penetrate the further applications and use of green hydrogen. Thank you.
Yes, yeah. Do we have a microphone? Yeah.
Can we have a Delhi, Bombay, like a dedicated freight corridor? Can we have fueling stations along that? Something like that of that. I mean,
so I think if I mentioned, earlier, I think that the about 40, 50 first set of pilots which we are going, exactly we are doing the same thing. We will pick up a few vehicles on a particular corridor. It could be 100 kilometers, 200 kilometers, like that. We will set up some fueling stations there, and we will see how these performances, what is the efficiency, what is there, or other challenges. And maybe we'll run some 10, 20,000 kilometers, 50,000 kilometers, and then we'll add some more routes, more corridors. And once it's true, we can't take the entire country's roads. We have to start with some kind of corridors. Thank you.
Yeah. And we've done that also. In the US, we have fueling corridors now, so both for EVs and for heavy duty. But one thing was interesting, if you look at some countries like Japan, Germany, they really invested in the stations, the fueling corridors, like 100 stations. What we did is we actually had much fewer stations, like only 50. And some of the countries that invested too early in the stations didn't have, they had stranded assets. Because they didn't have the zero emission vehicle mandate. And so it's really a mix. I think now when I see there's so much focus on production, electrolysis, and, the green molecule, which you need also, but I think it's a good point that we need the infrastructure and we need that demand side incentives, or sometimes even mandates. So I think that's great that MNRE is thinking about that. And so maybe if there are maybe one last question in case Abhay Bakre has to leave, if there's anyone in the audience, but okay, yes. And do you want to say your name and organization?
Yes. This question is from Mr. Abhay Bakre. My name is Meghna Sharma. So I'm very closely associated with the hydrocarbon industries, and most of my discussions have been around that. And Dr. Sunita Satyapal, I've been sort of directly connected with yourself as well. So my question is about hydrogen production, not the green hydrogen that we're talking about from electrolyzers and others. A lot of our traditional industries will require large-scale abatement as a first step. And we are talking a lot less about the abated hydrogen category, so by carbon capture and other methods. We still have resource that is really in the hydrocarbon sector, like coal. So India is very rich in the coal reserves, and that resource has to be properly utilized as well. So we are not talking a whole lot about abated hydrogen production and a lot about electrolyzer. So what is your view on that, and what is the policy direction in that regard as well? Thank you.
So the first question is that if you have heard about the carbon markets and the carbon markets Indian framework which we developed, so that is basically having an overarching aim of getting into 2030 goals, Panchamrit and beyond up to 2047. And so that's one thing. So overall, the industry will try to do the mitigations of GHG emission by whichever way it is most cost economical. That's the first thing. So if they want to electrify, they will go for electrification. If they want to go for captive grid, they can go. If they want to go for green hydrogen, they'll go for that, depending on which is the best value for their price against their CO2 reduction target. So that's the first thing. Second thing, if you talk about the policy direction, so the other kinds of the carbon capture, etc. Niti Aayog is piloting this. As of now, we are struggling currently the green hydrogen mission, and we have seen within last 1.5 years a good impetus and excitement in that. But we still talk about the cost. If almost in every meeting, the cost would have been definitely deliberated. So until it becomes exactly the same story, like solar coming from 18 rupees to 2 rupees, what Mr. Chintan Shah said initially. So we will continue to do that. Now, for carbon capture or the blue hydrogen, the carbon capture itself, there is another mission coming up. The deliberation is going on. Now, it's always there that the two missions, should they be competing each other? Again, the bottom line will be the price. So if it turns out to be that after 10 years, the carbon capture route is much economical, maybe then that the green hydrogen will become a second choice for the industry, and maybe the blue hydrogen could be the first choice. But as of now, I think it will be driven by the cost of these things. So both the missions will perhaps evolve based on their technicalities and the technology evolvement. Thank you.
Great, thank you. So we need an all of the above portfolio. But let's give a big round of applause for Mr. Abhay Bakre. And then we will, and hopefully you'll be back soon. Yeah. And so now we have just 20 minutes left. So we'll have a really quick Q&A. He has to go to another session, so we'll continue, just finish up in 20 minutes. And so the next question I'll ask for Mr. Chintan on, because we all know that sometimes there can be issues with IP innovation. We talk about cooperation, competition, co-opetition. And so I don't know if you can say a little more about when you think about the US-India cooperation and the impacts on innovation, tech transfer, just market development in general. Any thoughts on that with your activities?
Yeah, I have this answer about what a joint venture is. So, for example, you might have the best technology in a car. Maybe everybody knows either Mercedes, Audi, or Maybach, or some excellent car from US and all. But you still require an Indian driver to drive on Indian roads. That's what JV is about. You can't do the reverse. It will be a dangerous proposition. In India, we have very successful joint ventures, and India is a very matured market. What we are talking about here is cooperation at two different levels. One is at a project level, where people will bring in their core expertise. Like renewable energy player will bring its RE expertise to bring down the cost. Then you look at an integrator who will essentially integrate the compressors, the electrolyzers, the ammonia plant, and all. Very different set of skill sets they're talking about over here. And finally, storage, transportation. All put. But this is something which I would say, maybe across the globe, maybe one or two companies has entire expertise under their balance sheet. Nobody has it. So this is the age of cooperation. And I think India today is quite open about actually getting a joint venture or a co-developer mode at a project level also. That's one part. The other is a supply chain and manufacturing. When I say over there, obviously we have to access the Indian market. We have a very positive environment in India right now about manufacturing. Been firing on all cylinders. A lot of people are getting into manufacturing mode over here. Fair amount of skill sets you got over here, local market also. The whole idea is obviously it's a choice. We actually on this table we saw somebody typed with Kirloskar, and Cummins already has a fair amount of ventures in India. I think fairly successful. I don't foresee that as a problem. So that is also needed. So we have to look at entire ecosystem of wherever these gaps are there to fill it up on a cooperation basis. And this is ultimately at the end of the business because everybody stands benefited for this entire thing. And I don't think IP is a much of an issue over here. But I do agree that IP is important and has to be honored. And I think the country today is at that maturity level of appreciating the IPs.
Yeah. Great. And I think this is actually hydrogen's a good example as opposed to PV, for instance, because we have so many different pieces of the value chain. And so that really incentivizes that cooperation because it's hard to be like completely vertically integrated. And so having those joint ventures, addressing from production, all the different pieces to end use, and even within the one component itself, like electrolysis or fuel cells, you have the supply chain, you have all the different pieces like bipolar plates. And so I think it's a great, example of how it lends itself to cooperation anyway, because there's so much opportunity, and then actually there's such a lack of the supply chain and, experts across the way. So that's great.
Just to add one thing, if you are looking for speed, be here.
Yeah.
This is very good with speed.
That's great. Yeah. So we'll do quick 1 minute answers for each of the others, and then we'll open it up. And so for Kareem, it was great to hear, your perspectives, as you saw that not that many people were familiar with PDC, but especially when it comes to infrastructure. We talk a lot about the electrolyzer, but there's a lot else in terms of refueling. And so what are your thoughts in terms of, how can we solve the infrastructure problem and, opportunities for collaboration? You already gave a, good overview, but specific ideas on addressing infrastructure, and then we'll go to.
Yeah, so I'll speak on mobility infrastructure. So certainly in the mobility infrastructure, there's a whole piece of value chain in there, right? So there's compressor, hydrogen storage, chilling if you're going to 700 bar, even T20 if you're filling many 350 bar vehicles, and dispensers. And really the opportunity here is technology sharing, is cooperation, co-opetition opportunities here. In the end, leveraging we look forward to leveraging our experience in various parts of the world in the Indian context, right? So there's unique codes and standards, there's unique approval processes that have to happen here. And we look forward to leveraging our experience that we have seen in other parts of the world, and how can we maneuver and manage that here. There's a lot of the value chain that has to be developed, and we have to start from somewhere. So looking forward to the first one.
Yeah, and I think that whole topic of standardization, certification, we talked a lot about PESO. How do we enable 700 bar? Those are the kinds of things that we can do within the US-India task force, the industry task force. And did you have a quick question? And can you say your name again? Yeah.
With the small ecosystem builder type organization, we want to ideate to get people together. My challenge is with working with startups, they won't have many pieces of the equipment or test rigs. And I'm kind of, I know a number of them have approached me to, can we design our own compressor? So so folks have been telling me, no, go find something from somewhere. And so I want to come back to you and see if we can get a really small scale commodified version of a compressor. And also I want to pick your brains on your innovation process because I think all of you have done some phenomenal innovation methodologies, I think, which we can use in our startup ecosystems. So thank you for that.
Thank you. We'll be here afterwards to chat.
Great. And then for Dr. Balsu, who did a great talk. Hopefully you saw that the differences, the unique aspects of AEM, still early stage. But if you can talk more about your needs, you already did. But are there opportunities for collaborate? How can we really accelerate progress and get to scale up? So any thoughts there on your needs?
Absolutely. Yeah, thank you. I start by giving two examples. When you look at India, we went from some N number of landline phones to 10 times that many cell phones in a matter of few years. We just completely leapfrogged technology. The other example is here, right? This cell phone was used as a cell phone as one. The other is I was able to make a payment of 40 rupees for a sugarcane wala on the side of a road using PhonePe. Went directly from cards, skipped the cards, and went to PhonePe, right? Two examples where the country leapfrogged from technology A, skipped technology B, and went to technology C. There is a possibility that can be done for AEM as well. And the way to do that is you need to build two things. That's where we need to collaborate, cooperate, and also co-compete, right? Cooperate, yeah, whatever. Sorry. The two subsets of that is one, to build the skill set, people who can do this work. That can be done by taking technology that is indigenously developed from technology readiness level 3 to 6 by making these test systems possible, common test systems where you can have people, engineers and scientists who have the skill set to be able to do that. And along the way, we also need to build an ecosystem of suppliers. And the reason I pick AEM for supply-based development is, unlike PEM, there are a lot of difficult things in PEM, and the cost for PEM is high because it's not because people don't know how to make a platinum thing or an iridium or something. It's just very, very limited supply base. A lot of these also have very high level of technology that can only be done by 2 or 3 companies in the world, right? If you're like that, the cost will come down, obviously, but the price is never going to come down. For the price to come down, you definitely need a large supply base, and that can be done when you can start from material that is not limited, that is not made by only 2 companies in the world, that anybody can make it with some effort. You need to build that supply base. In this case, I said we need to build that supply base. That's where I live. Sunita, thank you.
Yeah, no, thank you. And I think, again, we can't let the perfect be the enemy of the good. We have to start. So we're investing in PEM. We have solid oxide, AEMs, because it's going to evolve and we can't wait. So we need big players. We need the installations. We need deployment, safety codes and standards. But again, we need to think about this as kind of future proofing, modular,
absolutely.
flexible enough so you can come in with new technology. And so that's why we need, all of that.
Yeah.
And
Chintan,
then,
if you don't mind, 10 more seconds. I want to agree with Chintan here. I'll give you one example that happened actually this week. You mentioned if you want speed, come here. Okay. Last week, I told my team member to make a design for a leak check fixture. Before my team member could finish the design and send it to me for approval, my supplier in India had made that leak check fixture. I was able to do the leak check with them, do initial testing. It's not perfect, but it is progress. All happened in less than a week. Progress over perfection. Do it fast, learn fast, fail fast, go from that. Thank you.
yeah, no, that's great. And so maybe we'll have 2 more here. So Anil, given that you already have lots of collaboration in India, talk about Tata, Gale, maybe just a little bit more on what are some of the challenges you talked about. We're all trying to move faster and we hear great examples, but since you've been doing this for a while, legacy company, what are some of the real challenges that you face?
So thanks, Sunita, for that question. And for the challenges, I just want to step back a bit and want to talk about how the hydrogen as a market in India is available today. So roughly, hydrogen is not something new for India. We produce about 5 to 7 million tons of hydrogen every year, depending on how is the monsoon, because fertilizer is a big consumer of hydrogen and then ammonia, and how the economy is 5 to 7 million tons roughly. Also, the fact is 99 plus of that percentage is a gray hydrogen, right? So today the green hydrogen or even a blue hydrogen is very minuscule. So from there, we're talking about reaching to 12 million tons as an overall hydrogen economy by 2032. That's the target India has. And out of that, we want to achieve 5 million tons of green. We're talking about from almost 0.5% today to going about almost 40% by next 7 to 8 years. So that's the gap we have. And what's the scenario today in the market? In the reality is that, and most of the companies are talking here that there is no demand, right? And of course, we see a lot of spectrum of opportunities. It's not like customers do not want to get into. But the thing is that when there is a proposal for green hydrogen for the companies to discuss a business case, who is taking a final call? Is it a chief sustainable officer who is taking a final call on those investments, or is it a CFO who is taking a call on those investments? And from a CFO perspective, the matrix is very clear: return on investment, return on equity, return on assets. And today, the green hydrogen doesn't tick box any of those things. And that is where we are not seeing the projects moving from pre-FEED, FEED to FID stage. So I think this is the biggest challenge. So what needs to be done? We're talking a lot in the last 2-3 days and multiple conferences. We want government to continue its proactive response in order to bring the focus on green hydrogen. So subsidies need to be continued. That's one. Second, importantly, also is some kind of a mandates, because unless and until there is some mandate for the industries to opt for green hydrogen, why somebody will really go for it if there is not a business case today, right? And people are talking about it. So Bakre talked about it in the morning. If somebody of you must have been there in the SECI dialogue, SECI MD talked about a kind of a mandate might be required for the industry to incentivize and adopt green hydrogen. That's something is needed. And third challenge also is this is a nascent industry. And in my view, and this is my personal view, it may not be necessarily the view of my company, is that we're getting to, of course, the pricing is important. But at the same time, we're getting too early on some of the tenders on L1 and reverse auction. Because what will happen in that case is probably the technology which is best in class may not get the space to prove itself. And that's the biggest. If you're talking about only the lowest price for the technology at this point of a time, where is the R&D coming in? Where the innovation is going to happen? And that is very important. Probably government, even the companies from private sector need to look into that. They have to come out with the demonstrator projects, maybe 10, 20 megawatt, not necessarily in a gigawatt scale, wherein we don't have the criteria for a price for the first 1 or 2 stages. The criteria for the efficiency, reliability, durability, safety. Safety is extremely critical, right? We're talking about hydrogen is, one of the challenges for hydrogen is safety. How can we have those demonstrator projects looking beyond the price, at least maybe for next 1-2 years, so that we have a very sustainable hydrogen economy going forward? And there's a space for startups, for the established companies, and for all technology companies, in order to build this ecosystem together. Thank you.
That's a really good point. I think having that entire TRL, like we are funding early stage, mid, de-risking, first of a kind demonstrations. There's just so much hype on hydrogen, and we're not necessarily ready to get to full deployment. So really good point on the challenges. I know we're running out of time, so the last one we'll have to Kiran, which you already talked about, great examples of collaboration, the slides, but maybe again, and we know offtake, we've heard some of the big challenges, but you can talk again about what do you see are big challenges as we think about the collaboration and then accelerating progress.
Sure. I think collaborations totally depend on, I think, the demand in the market. So one, I definitely like the incentives part, but I think demand side is what will create the pull. So once there is a pull, I think market forces will evolve and collaborate in all possible ways. I feel the market is so huge that people will not have time to really compete because the market right now is small. I mean, it looks like there's a lot of competition, but there is huge amount of capacity required. That is one part. The other thing is what we have been doing is we have taken the technology, we have scaled it up, we are doing real things on ground. And that is very important for the hydrogen sector because this is not some theoretical thing. This is not just like solar that you can easily replicate. The number of operating hours you have both on fuel cell or the electrolyzer side is really, really important to scale and reduce cost. So that is what will kind of help accelerate the adoption. So we not only produce, but we have deployed it, we are operating it, we know what goes in, what can fail. I think that is very, very valuable. And the misconception that PEM is very expensive and all, I would completely disagree with that because by the time the new technologies will scale, the PEM cost will come down significantly, right? And with more proven technology. So I think that way, I think it should not be a in between technology competition, but rather evolving the whole ecosystem. We need all technologies, and the different technologies will have different spaces where they will dominate, and but there are also spaces where they will compete. I think which is what the market will take care of. Thank you.
Yeah, I think that's a good example too. When we talk about VHS and beta in terms of the video, it's not the situation. It's not a similar situation because they'll be different. If you have high temperature industrial, let's say, or nuclear, the high temperature solid oxide could be the right fit. So I think that's a good point. Since we're out of time, I think maybe the one thing I'll mention, since we have US ISPF here, Starth, if you want to folks stand, because they're the secretariat for the US India task force, the industry task force, and Tevleen here from our State Department too. And if others are here, feel free to coordinate. And is there anyone here who would be interested in joining the industry task force? Because we will have active working groups. We just had a meeting yesterday. So if you can raise your hand, again, if you're from industry and are interested in engaging, feel free to talk to USISPF and Tevleen. And then we're looking again for very concrete actions. Again, this will be led by industry to help address some of those challenges. And so with that, I know we're out of time, but what I'll do is, and for me also personally, you can see many of us up here. And since my parents actually left, they lived in India. They grew up in India and they left long ago before I was born. So I never lived here, but have visited, and obviously a great example of US-India collaboration. So it's always great to be back to visit. I'll be leaving soon for the airport, but just wanted to say, a big thank you to all the hosts and everyone put this together. And a big thank you to our panelists, those who came all the way from the US, those who are here. And I think this is such an exciting time. So for me personally, being in the space for almost 3 decades, of course, I started when I was 4 years old, but we just have to get it right now. And so it's great to see so many new players here. The last thing I'll mention for people who might not know, we also have a government partnership called IPHE, International Partnership for Hydrogen Fuel Cells in the Economy. You can go to iphe.net. And with 25 countries, I'm also a vice chair on that. And again, coordination, leveraging as much as possible. So there's a lot happening there as well. India is a partner country on that as well. So stay tuned to that, and Breakthrough Agenda, where we're coordinating across, all the different initiatives. So with that, let's have a big round of applause to all of the speakers. Thank you.
Thank you so much, chairpersons, for chairing this session. It was indeed a very valuable session, knowledge enhancing session, I should say. And thank you so much for sharing the valuable inputs. Can we all get our hands together for them once again? I now request our moderator to honor or to give a token of thanks to all our panelists out here, one by one. I request Dr. Sunita Satyapal to kindly give the token of love, this beautiful memento, a token of thanks from our side, to Mr. Chintan Shah, Group President and Global Head of Strategic Business Development and Policy Affairs, Renew Power. Ma'am, please come in front. There, at the center. Loud applause, please. I request Mr. Kareem Afzal to kindly come forward, the Executive Chairman, PDC Machines. Loud applause, please. I request Dr. Balsu Lakshmanan to kindly come forward, Chief Technical Officer, Versogen. Loud applause, please. Mr. Anil Kale, Sales and Business Development Leader, Accelera, Electrolyzers, India. Loud applause, please. And I also request Mr. Kiran Alla, Senior Director, Business Development, Plug Power, India. Loud applause, please. And now it's time to give a beautiful token of love and thanks to beautiful ma'am. That means Dr. Sunita Satyapal. And for the same, I request Mr. Siddharth Arora, our knowledge partner, to kindly give this token of thanks to Dr. Sunita Satyapal, Director, U.S. Department of Energy's Hydrogen and Fuel Cell Technologies Office. Let's have a beautiful group photograph together. I request all the dignitaries, all the panelists to kindly come forward. Let's join together for the much awaited and a memorable group photograph. Thank you so much, everyone, for joining us and making this beautiful, amazing, lovely session such a wonderful one by your lovely presence, your support, and your cooperation. Thank you so much, everyone. This is me, Anchor Simran, signing off. Thank you.